In this video, we are going to discuss about the one-dimensional Helmholtz problem. So I have the one-dimensional Helmholtz equation, which is of this form: u double prime plus k squared times u equals 0, where k is the wave number. And my question is, what is the general solution? We would like to find a general solution for this ordinary differential equation. So the first step is to write the characteristic equation The characteristic equation is P of lambda is lambda squared plus k squared. And I have to solve this equation, so I take it equal to 0. This can be written as lambda squared minus ik squared, where I is the square root of minus 1. So from here I have lambda minus ik times lambda plus ik equals 0. From here, lambda minus ik equals 0. So lambda plus is 0 plus ik, and lambda plus ik equals 0. So lambda minus is 0 minus ik. Now my general solution is of the following form. Is u of x is c1 times e to the raised to the real part of lambda plus times x times cos imaginary part of lambda plus times x plus c2 times e real of lambda minus times x times sine imaginary lambda minus times x. The real part of lambda plus is 0. So here I have c1 times cos, and the imaginary part of lambda plus is k. So this is c1 times cos kx plus c2 times sine minus kx. So this can be written in the following form: c1 cos kx minus c2 sine kx. And this is my general solution. Where c1, c2 are real numbers, so these are arbitrary coefficients. So I have obtained my solution, and now I can check if this solution satisfies my ODE. So I take the function u of x is c1 times cos kx minus c2 sine kx. I take the function, I compute the first derivative, So this is minus k c1 sine kx minus c2k cos kx. I compute the second derivative of the function. So this is minus k squared c1 cos kx plus c2k squared sine kx. I have u double prime plus k squared of u double prime is just substitute, and I want to verify that this is equal to 0. So I substitute the second derivative of the function and the function u and check. This is c1 cos kx plus k squared c2 sine kx plus k squared, and my solution is c1 cos kx minus c2 sine kx. Some calculations are necessary in this stage. So this is plus k squared c1 cos kx minus k squared c2 sine kx. Of course, this term with this term vanish, this one with this one vanish, and this is 0. So u double prime plus k squared of u equals 0. So my solution, of course, I can rewrite it, is u of x is c1 times cos kx minus c2 sine kx. This is my general solution. Helmholtz problem is very popular in engineering and in science because there are many things that you can model with the Helmholtz equation, and I have used it during my thesis. It is one of the most difficult problems in numerical analysis, and it requires a lot of efforts, computational efforts. So there are global projects, research projects. There are people that make a living on the Helmholtz equation and how to solve this problem efficiently using numerical methods. Thank you very much for paying attention to the video, and I hope that this video finds you in good health and spirit.